I'm Pete.
I'm Meza.
And this is Ethan. And today we're talking about Unit 4 in AP Physics, momentum. Alright, the first topic is linear momentum. So basically what momentum is how hard it is to stop something. And there's two main factors when calculating momentum: how much mass something is and how fast it's going, so the acceleration. For my first example is, imagine a shopping cart, an empty shopping cart. If I'm pushing it real slowly, it's going to be super easy to stop it. But if I have a shopping cart full of groceries and I'm running full speed with it, it's going to be a lot harder to stop it. That's basically what momentum is. And we'll show you a real life example. So as you see here, Meza is walking slowly. He weighs about 130 pounds. And so he doesn't have much momentum. But me, I weigh about 160 pounds. And if I take off like that, then I obviously have a lot more momentum. So I'm going to be a lot harder to stop than Meza, who is walking very slowly and is about 130 pounds.
Okay, so the first topic is linear momentum, and the equation for linear momentum is P equals mv, with P being momentum, m being mass, and v equal velocity. Momentum can be defined as the amount of motion an object has. Momentum depends on both the mass and the speed of each object. A quick example of that statement would be a truck having more momentum than a fast-moving bicycle because the truck is heavier. And then the kilograms, or for the units, would be kilograms, would be kg times m times s. And then to connect this to real life, we could relate to things such as sports, car crashes, bowling, and football tackles.
Next is change in momentum and impulse. Impulse is what changes an object's momentum and direction. For example, it's like catching a football, throwing a baseball, or kicking a soccer ball. A real life example is when my foot applies a force over a certain amount of time, changing its momentum and direction, which is aka impulse.
Okay, the next topic is change in momentum and impulses, and the equation for a change in momentum would be change in momentum equals mv final minus mv initial, and then for change in impulse, it would be impulse equals force times time interval equals change in momentum. Change in momentum happens when velocity changes. To define impulse would be impulse is the force applied over time to an object, and then for the symbols, capital J is impulse, capital F is force, and then delta T would be time interval. Larger force or longer contact time changes momentum more, and some real life examples of change in momentum and impulse would be airbags increase stopping time to reduce the force, and then catching a baseball by moving your glove backward. So example of that would be you have the glove and then the baseball coming, move back, so the force spreads evenly. And then you can also, a key thing is that impulse and momentum are directly related to each other.
The next topic, and our third topic, is the conservation of linear momentum. So what this means is energy is not lost during collisions. So a good example of this is whenever you're playing pool and you hit the cue ball and the cue ball rolls and hit the ball you're trying to hit, even though the cue ball stopped, the other ball is still rolling, which means no energy was lost in the transfer momentum.
You're in frame.
Oh my gosh. So even though Meza hit me, and then I went flying back, and Meza stopped. So what this shows is that even though Meza lost all his energy while hitting me, I gained all the energy because I gained momentum when he hit me. So like how you're outside, when Meza was going about 10 to 15 miles an hour, once he hit me, his car completely stopped because I was just so strong, I guess. But I still went flying back about 15 to 20 feet. But, however, no energy was lost. Even though Meza's car completely stopped, all his energy just transferred into me because of the change in linear momentum.
Okay, so for the next topic is conservation of energy. And the equation for conservation of energy would be kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. And to relate conservation of energy, you have to go through the law of conservation of energy. And the law of conservation of energy states energy cannot be created or destroyed, it can only be transformed. And to explain the equation more, KE, capital KE equals kinetic energy, and capital PE equals potential energy. And energy can change forms in many ways. An example of this would be a roller coaster converts potential energy into kinetic energy. Kinetic energy can also be displayed in a lot of practical applications, including pendulums, falling objects, and amusement park rides, as they all use conservation of energy.
The next topic would be elastic and inelastic collisions. Basically, an elastic collision is when two objects collide and bounce away from each other afterwards. An example could be a trampoline. When I bounce on a trampoline, me as an object bounces away from the elastic part, the trampoline. An example for an elastic collision is when me and Pete collide and change our directions without losing energy or momentum.
Okay, and for the next topic, it'll be elastic collisions. And the equation for elastic collisions would be M1 times V1 initial plus M2 times V2 initial equals M1 times V1 final plus M2 times V2 final. Or you could simply do kinetic energy initial equals kinetic energy final. And to define an elastic collision would be both momentum and kinetic energy being conserved. And then examples of an elastic collision would be objects bouncing apart after colliding.
Inelastic collisions are different because when two objects collide, instead of bouncing away, they stick together and change to a different kind of energy. For example, when clays be thrown at a wall or a surface, it sticks to the surface and loses all momentum and changes into a different energy like heat, sound, or damage. An example of an inelastic collision is when me and Pete collide and lose all our momentum and change our energy into something else.
Okay, and for the final topic, it'll be inelastic collisions. And the equation for inelastic collisions would be M1 times V1 initial plus M2 times V2 initial equals parentheses M1 plus M2, parentheses closed, V final. And then some points about inelastic collisions would be, to define an inelastic collision would be momentum is conserved but kinetic energy is not. And then to compare inelastic collisions to elastic collisions is that momentum stays conserved in both, but kinetic energy only stays conserved in inelastic collisions.
This is Pete.
This is Meza.
And this is Ethan. And thank you for watching our Unit 4 AP Physics lesson on momentum. Tune in to next time.
One is the loneliest number that you'll ever do.